On behalf of Netnology, welcome to another demonstration segment of the Cisco Be Boundless initiative. Cisco is doubling down on integrating cross-domain architectures which address customer business needs. These simple cross-domain integration examples span Cisco SDX and cloud architectures and solutions while having a laser focus on security, analytics, and automation without technology barriers. In other words, one part of Cisco making another part of Cisco even better. Be Boundless. Netnology is one of the top integration partners and a Be Boundless champion, working hand in hand with Cisco to make Be Boundless a reality. Welcome to the Cisco ISE and ACI integration demo. We will demonstrate some of the configuration and show an example of the integration in a live lab environment. Cisco TrustSec provides software-defined segmentation to reduce the risk of malware propagation, simplify security operations, and assist in meeting compliance goals. Controls are defined using endpoint roles, not IP addresses. The TrustSec ACI policy plan integration helps in addressing the breaches, segmentation, and compliance challenges by sharing policy groups between TrustSec-enabled networks and ACI data centers. It enables consistent security policy management across the enterprises by leveraging user roles and device type together with application context anywhere in the network. The complementary group-based policy approach used by TrustSec and ACI vastly simplifies security design, operations, and compliance. Cisco TrustSec and application-centric infrastructure, or ACI networks, are similar in semantics to group-based policy framework. Users and resources in both networks are categorized into groups, and access is provided across groups. However, Cisco TrustSec and ACI differ in syntax and representation of group identity and its propagation across the network. For instance, Cisco TrustSec networks use security group tagging, or SGT, while ACI networks use endpoint group, or EPG. Prerequisites for Cisco ISE and ACI integration ensure that Cisco TrustSec Protected Access Credential, or PAC provisioning configuration, is done on the device and the PAC is downloaded from the Identity Services Engine, or ISE. Ensure that connectivity is available between ISE and ACI. 802.1x authentication configuration on the switches. Active Directory is integrated into ISE for user authentication. An ACI tenant is created along with the necessary VRF, BD, AP, EPGs, and L3 out is created for the tenant. This demonstration was performed using ISE version 2.4 patch 8 and ACI 4.1.1i. Please reference the applicable Cisco documentation for the software version in your environment. This is the topology we will be using in this implementation example. We have two servers, Web and DB, that each exist in their respective EPGs in an ACI environment. The ACI fabric is connected via an L3 out to an external fabric, which in this case is a single Cat 9300. Behind the Cat 9300, we have a user environment. This is where our example users will originate their access to the Web and DB. For this use case, we are using Active Directory services and ISE integration to grant the users appropriate permissions and drop them into the external EPG to which they belong in ACI. These external EPGs have specific rules that allow or deny them access to the internal Web and DB servers. Next, we will briefly look at the minimum switch configurations required for the device external to the ACI environment. The following needs to be configured for the integration to work. It is assumed that this has already been performed. AAA configuration completed on access switches. Active Directory is integrated with Cisco ISE. Users are created in Active Directory, and roles are defined. Let's begin our live demo. First, we will look at getting the certificate from ACI loaded into ISE. Here we are logged into ACI environment. We will simply open the certificate details in Chrome and view the certificate from ACI. From the Details tab, we copy to file this certificate, or in OS X, we can drag the icon to a Finder window. If you are using Windows, use the Certificate Export Wizard and select Base 64 Encoded X.509.CER option. Click Browse and type the name of the ACI certificate that we copied to file. Click Next, and then Finish. The next step is to import this certificate into ISE. From the ISE dashboard, navigate to the Administration System Certificates section. Click Trusted Certificates and import the certificate that you just exported. Check all the boxes for Trust for Authentication within ISE, Trust for Client Authentication in Syslog, Trust for Certificate-Based Admin Authentication, and Trust for Authentication of Cisco Services. Now we can integrate ISE and ACI. The integration with an authentication source is essential for users to authenticate when accessing network resources. This could be Active Directory, or AD, or any other external authentication server. In this example, AD is used for authenticating users. If we log into ISE and navigate to Administration, Identity Management, External Identity Sources, we can select Active Directory and click Add to make this an authentication source. For this, you'll need to enter the join point name, Active Directory domain, and click Submit. In this case, we have a basic setup with a single ISE controller, so we would respond Yes to join all ISE nodes to this Active Directory domain. Now that we have integrated the identity source, we can look at the security groups that we have created in AD. These are important because they will ultimately determine if our users can access the DB or web servers. You will need to create similar policy based on your requirements and make sure that your users are members of the groups they belong to. We also need to browse to Administration, System, Development, select the deployment node, enable SXP service, and save. SXP will bind IP addresses with SGTs and the external EPGs. Next, navigate to the Work Center's TrustSec Settings section and select the general TrustSec settings. In Optional Additions, check the box for prefix and type in SGT. Now click the SXP settings. Enter the global password CTS SXP default password from the switch configurations and save. Next, click the ACI settings and check the box for TrustSec ACI Policy Element Exchange. For ACI integration, select Policy Plane and then enter the ACI cluster details. Make sure to test the settings before moving on. Now we are ready to propagate the SGT to ACI. Navigate to Work Centers, TrustSec, and click Components. Now select Security Groups and click Contractors. We will check the box for Propagate to ACI and save. Then repeat this as necessary for employees and any other security groups you may have. This completes the ISE configurations. Next, we need to implement some policy in ACI to complete the access. In the APIC GUI, navigate to your tenant and expand to Contracts, and create any contracts needed to allow your endpoint groups to communicate. These contracts will then be applied between the external EPGs and the internal EPGs. Here, we have simple contracts for ping. One we will use for allowing contractors access, and one for allowing employees access. Next, the contracts just need to be applied. In this example, we want contractors to access only the web and employees to access both the web and the DB. If we navigate to the application profile for our example, we can see how we apply these policies. The external EPGs created by ISE have consumed the contracts, and the internal EPGs, web and DB, are providing the contracts. We can see that the web is providing to both contractors and employees, while the DB EPG is only providing to employees. Now, all the policy we need is in place. Next, we can verify everything is working. First, we can take a quick look at our employee external EPG. We can see that there are no routes being learned yet. So let's log into our host as an employee and verify this works. Here, we log in to access the network in our Windows 10 machine as an employee. Now back in the external EPG of ACI, we can see that our host route is learned in the external EPG. Finally, we can verify the end-to-end SGT to ACI integration and that all policies are functioning by doing a simple ping test, first to the internal web EPG and then to the internal DB EPG. Next, let's log out of employee access and log in as a contractor and verify we can access the web but not the DB and see that the external EPG subnets have updated in ACI. Here we can see that our host route has been removed from employees and is now in contractors. We will run our final ping test to check the security is functioning. We will again try to ping the web. We can see this works. And now we expect that the DB will fail. This confirms everything is working perfectly. For further details of this integration example, please refer to the step-by-step integration guide. This concludes our demo. From all of us here at Netnology, thank you for watching.